All right, good morning, everyone. Kind of not feeling well today. I started feeling bad last night. So I'm going to try and wing it here. I thought about canceling class, but I wanted to be here to be able to talk about the finals. So I sent out an email yesterday that showed which problems from exams 1, 2, 3, and 4 for you to go and take a look at. And I also sent you copies of those exams so you can go back and actually look at the problems. And then I just sent to you right now another file, which I'll bring it up here because I just sent it. Where is it? Oh, okay, here we go. So I sent this, and this has the answers to those problems. I actually didn't. If you open up the file, here's what it looks like. It's actually one of your classmates. This is their problems for exam 1, numbers 4, 5, 9, 12, and 13. So you can see those answers. And if you keep going, then it'll bring up exam 2. This is just the whole exam. All the answers for exam 2, all the answers for exam 3, and then all the answers for exam 4. So you now have a copy of each of the problems I told you to look at, right? You have the solutions for each of those if you need to refer to those. Now, in addition to these problems, and I didn't put this in the email, in addition to those problems, you will also have problems from last class, which was the solving systems of equations. And I asked you to do what, 2, 5, 7, 8, and 9, I think. And then I told you to look at these word problems and that you could turn these word problems in as an extra credit. You just turn those in with your final exam work. So are there any questions over any of these problems that I gave for homework? Any of these systems of equations? Do you want me to go over any of these?
I had a problem on number 12.
Number 12, okay.
I didn't know how to set that one up.
Yeah, okay, this one's a little tricky. What was it, number 12 and number, which one was it?
12 and 16 I had trouble with.
Yeah, 12 and 16 are very similar. So let's look at number 12. We'll take this, do this on a different page. All right. Okay, so it says on a farm, there are pigs and chickens, right? There are 7 more pigs than chickens with a total of 58 feet. Feet meaning like your feet on your body, right? Not feet as in measuring feet. So a total of 58 feet. How many type of each animal are there? So did you assign a value for X and Y? Like, did you say, let's let X be anything or Y be anything?
Yes, I said X for pigs and Y for chickens.
Okay, so X is going to be the number of pigs. Y will be the number of chickens. Okay, so is there anything that you can tell me from this information? I mean, you're only really given 2 things, that there are 7 more pigs than chickens, and then you're told that there's a total of 58 feet, right? So let's think about this. A pig, obviously a pig, this is a pig. That's a pig. A pig will have 4 feet, right? 4 feet per pig. And then your chicken, I'm not going to draw a chicken. There's 2 feet per chicken, right? So how could we figure out the 58 feet? That's going to be however many pigs we have times 4 for each, right? For each pig, we have 4 feet. So we're going to have to write 4 feet for each pig. So 4 times X. Does that make sense?
Yes.
Okay. And then plus we'll have 2 feet for each chicken. So 2 times Y. That should total 58. So that's one of the 2 equations. I'm going to guess that you got that. Did you have that?
Yes, I did.
Okay, it's the other one that's hard to get. And you
Yeah.
have to get from this right here. So it says there are 7 more pigs than chickens. 7 more pigs than chickens. So let's just think of this, let's just pick some numbers. Let's say that there were 3 chickens, okay? How many pigs would you have? If you have 7 more pigs than chickens, if there were 3 chickens, how many pigs would you have to have?
10.
10, okay, 10 pigs. If there were, let's say, 4 chickens, I'm just going to say C, 4 chickens, then there would be 7 more, so 11 pigs, right?
Yes.
If there were 10 chickens, then 7 more than that would be 17 pigs. But how many chickens do we have? Do we know how many we have? We don't, right? But what are we calling it? What are we saying the number of chickens is?
We're just calling it X.
Other way around, chickens, right? We're calling it
Y,
Y,
sorry.
right? No, it's all right. So we have Y, right? Y is the number of chickens we have. If we have Y chickens, then how many pigs would we have? 7 more than that, right? 7 more. So this would be that Y, whatever it is, plus 7. That would be the number of pigs we have. Does that make sense so far?
Yes.
Okay, so what we can say is that this right here is the number of pigs, right? This is the number of pigs. It's 7 more than the number of chickens. So, but the number of pigs is X. So we can say, from this, we can say X, that's the number of pigs, has to be equal to Y plus 7. So the number of pigs is 7 more than the number of chickens. The number of pigs is 7 more than the number of chickens. Does that all make sense how I came up with that?
Yes, it does.
Okay, so now what you would do is you need to get your equation to look like the other one. So I would just subtract Y on both sides. So that it looks like this, X minus Y equals 7. And that will be the other equation. There's your system. And I'll be happy to work through that, but that's the setup. And I think the setup is the hardest part in these problems. Does anyone else have a question on that one? Should I work it out, or what do you want to do?
I don't have a question, but I'm just a little confused because I thought you would do like 7x minus y, but that would mean it would be like 7 times the number
That's
of
right.
pigs.
That's right. It's the key word here is more. So when we think more, like if I have 7 more dollars than you do, then you would take however many dollars you have and add 7, right? If I said I had seven times as much as you do, then I would do multiplication. So the more tells us we have addition.
Oh, okay, I get it. So pigs x is equals to the amount of chickens and then an additional 7.
That's right.
Okay.
Yeah. It's the language of that's hard to figure out. You just have to read through it carefully. There are 7 more pigs than chickens. So we're not adding 7 to the number of pigs, we're adding 7 to the number of chickens. That's why I did this first. Because if you think about it, if you have 3 chickens, you're supposed to have 7 more pigs than you have chickens. So 7 more would be 10. I hope that clarifies it.
Yeah, I did. Thank you.
Okay. Now, number 16 is very similar to this one because it has some similar language in it. So let me help you get this one set up. Okay, a nurse is ordering 2 different kinds of medicine. Medicine A costs $7 per gram. Medicine B costs $9.75 per gram. The total bill is $268.50. And the nurse orders 24 grams more of medicine A than medicine B. This is just like the chickens. This is just like saying we had 7 more pigs than chickens. Here we have 24 grams more of medicine A than medicine B. So the question is how much of each medicine is ordered. So let's say X is the number of grams of medicine A. Let's let Y be equal to the number of grams of medicine B. All right, so let's try and set up the harder part first. Nurse orders 24 more of grams of medicine A than medicine B. Can somebody tell me what I would do there? If medicine A is X and medicine B is the Y, then what would be the equation that I need to write there?
Would it be y equals 24x? Or no, 24 plus x.
Okay, so it could be that, or do you agree it's either that or it's this one, or it's the other way around? Do you agree that it's one of those? It's either Y is 24 more than the X, or the X is 24 more than the Y. Do you see that it's going to be one of those two?
Mm-hmm.
Everyone see that? So which one is it? I think this is the confusing part. So I think this is where you just make an example, like just take an example for yourself. Let's say this medicine A, medicine B. Let's just make like a little table here. What if we had, let's say we had 10 grams of medicine B. How much medicine A would we have? So read it. We have 24 grams more of medicine A than we do of medicine B. So if medicine A is 24 grams more than this, shouldn't that be 34 then? And if we had 20 grams of medicine B, then we would need 24 more. So that would be 44 grams. Is this helping at all, this table? Does this help kind of figure out which is which?
Yes, sir.
Okay. So remember, medicine B is the Y, and this is the X. So which one of these formulas works?
Would it be the second one?
It would be the second one, yeah. See, if we try this first one, let's see if it works. If we replace X with 34, go 34 plus 24, that doesn't give us 10. But if we put the 10 in here, 10 plus 24, that does give us 34 for X. And if we put 20 in here, we get the 44. So it's going to be this one. And I understand that's going to be the confusing part of this problem and the chicken and pig problem. That's the confusion. That's the part that's confusing. But I'm going to write the equation down. I'm going to also move the Y to the left side. So I subtracted Y here. I subtracted Y here. The Y's canceled. And that's my first equation. Now I need my second equation. And this is where the money comes into play. Medicine A costs $7 a gram. So I'll put 7x plus medicine B is $9.75 per gram. So 9.75y. That has to equal the total bill $268.50. So those are my two equations.
I have a question.
Yep.
Could you just leave the like the y equals 24 plus x? Could you just leave it like that and then substitute?
You can do substitution. Yes. Uh-huh.
Okay, but the way you're setting it up is for elimination.
Yeah, very good. Yes. You said if you leave y equals 24, we're not using that one. I think you meant could we leave it as
Right,
x
yes.
equals, yeah, okay, 24 plus y. Yes, you could leave it like that and then do substitution. I'd just move the y over so that we could do elimination. And if I were doing elimination here, I would multiply the top one by -7. And then that way this -7x and 7x would cancel. And then you should be able to solve for y. And then once you solve for y, you go back and get x.
Okay, thank you.
Uh-huh. Excuse me, I've got to blow my nose. Okay, so what else? Any of these other ones? Okay, so what I would expect on the test is problems similar to these, okay? So what is this? This is about 5 problems, 9, 10, 11, 12. I don't know, this is about 15, 16 problems so far. And then I'll ask you to solve, I'll give you a problem where you're gonna have to solve a system of equations, okay? Like either like number 2 or number 5 or like number 7 or 8 or 9, something like that, maybe just one of those. And you can use either substitution or elimination. I don't care what you use. And then I will also give you a word problem.
I have a
Okay.
question.
Yep.
When you give us the problems for a system of elimination,
Uh-huh.
the answer, is it just going to be x and y, or do you want us to graph it as well?
Oh, good question. No, the answer is just going to be x equals this, y equals this.
Okay.
Yeah, I don't need the graphs, like, because these are, when we're solving systems of equations, we're trying to figure out where two lines intersect. But that was just to give you a visual representation of what we're doing. You do not need to graph those on the test.
Okay, thank you.
Now, I believe that one of those review problems, if I'm not mistaken, I think one of these problems, maybe it's from exam 2. Let's see, 3, 4, 5, and 11. I think you do have to graph a line. Yeah. Because I ask you, this is exam 2, and I say to look at 3, 4, 5, and see number 5 is sketching a line. So make sure that you're prepared to sketch a line. So you'll need to be, go back. See here in this one, I give you, thing is annoying. I give you y equals something, right? But look at number 6, it's not solved for y. So when I say sketch a line, it could be either one of these. Don't expect it to look exactly like that. When you're reviewing and studying for the test, just be like, okay, I need to be able to sketch a line. There were 2 different ways to do that. There was the intercept method, and then there was the slope intercept method. So you want to go back in your notes and take a look at when we were sketching lines.
Okay, and are we also going to need the calculator that has like the natural log and
Yes.
all that?
Yep, because you'll need that for problems. I ask you to look on exam 4. You're going to have to be able to do these interest problems and continuously and stuff. So you'll need E. And then I believe I told you to look at number 6 and 7.
Okay.
Exam
Sorry, I have
4.
a lot of questions, but
Oh, it's okay, good.
are you going to provide like some of the formulas, or are we gonna have like a cheat sheet, or are we just gonna have to memorize them?
I'm glad you brought that up. That was the next thing I was going to talk about. So what I'm going to allow you to do on this exam is make your own formula sheet, okay? So when I say make your own, I mean, you will take, you will be allowed to have, so I'm not going to give you any formulas. I'm not giving you anything, all right? Just the test. So that means you're going to get a standard 8.5 by 11 sheet of paper. You can write on front and back. You can put whatever you want. Well, hold on. You can put whatever formulas you want on there. You can give yourself hints, like something like to solve an exponential equation, isolate the exponent, and then take natural log of both sides. You can give yourself steps and procedures for doing anything. If you want to graph a line, use the intercept method to find the x-intercept, set x equal to 0, or whatever, set y to 0, solve for x. You can give yourself as many little steps and procedures as you want on this sheet, okay? What you may not have on this sheet is just problems worked out, okay? You cannot have that. And I'm gonna have everyone on the day of the exam hold their cheat sheet up, and they're gonna show me front and back, and I'm gonna make sure that nobody has any worked out problems. Okay, so if you have worked out problems, I'm gonna tell you you can't use it and you'll have to chunk it. So, but that means you need to go through the review, right? Go through each of the questions, and then kind of as you're doing the problems, write down on your cheat sheet the things that you needed to know to do those problems. Okay? Any questions on that? Any clarification I need to make? When is our exam? When is the exam? We haven't even talked about that. It is on Thursday, okay? The test is on Thursday. That means next Tuesday coming up, we do not have class, all right? There is no class. Next week is finals week, which means you should only be meeting for your classes one time, just for the final. You shouldn't be meeting twice. So we are only going to meet on Thursday of next week. So this is the last time we'll see each other before the final. And we'll come in here at 9:30, but the exam is scheduled to go all the way to 12:15. Now, I don't think you'll need that much time, but that's the block of time you should have open in your schedule, okay?
What if it like interferes with another class?
It
Like,
shouldn't.
Okay.
It shouldn't. The way they make these finals, these schedules, is that's why we don't have class on Tuesday. It's because
Okay.
if you have another class on Tuesday, like, do you have another class on Tuesday?
Yeah, I have a class at 11.
What time?
Right
What time
after.
is that class?
It's from 11 to 12:15, but she hasn't talked about the final yet.
Okay, so if you had a class on Tuesday, Thursday at 11, that final would be on Tuesday.
Okay.
That way it doesn't overlap with us. It's weird. That's how they have to do it though, to make sure. So you should never have to be at two finals at the same time.
Okay. Okay. Thank you.
If you do, then that means one of your professors messed up. I'm pretty sure that I've got it right though. So. Okay. Now I need to warn everybody that the math department just this semester had a committee get together. I was not part of this committee, but they decided that there would be a set of problems that would go on to the final for every 13, 14 student, like every class. So there's going to be a set of problems on this test that I'm not allowed to show you what they look like, okay? I'm not allowed to prepare you for them. And it's just to see how y'all do with them. Now, I'm not real happy about the fact that they're forcing us to do it. But I'm gonna play by their rules, and I'm gonna put it on the test. I would say out of the 6 problems, 4 of them you'll be fine. because it's stuff that I've told you to go and review. Okay, so I'm telling you, go look at these types of problems because you're going to see this again. The thing is, it's going to perhaps look a little strange. Like the problems will look maybe a little different, but I promise you, it's what we've been doing. Okay, so you just need to kind of relax. If you see it, don't freak out. Yeah, so I just want you to be aware of that. I don't want you to get to the test and be like, what the heck, man, he didn't tell us that. It's going to look different, but it's the same sort of material. All right.
How are you gonna grade the final?
Very hard. Is that what you're asking? What do you mean by how am I going to grade it?
Yeah, like how many questions is like gonna be on the final?
Well, I would anticipate seeing somewhere around 20. I would say about 20. So if you look at it that way, each problem's worth about 5 points. I'm not
Okay,
sure.
thank you.
Yeah, and of course you always get partial credit, you know, as long as you're putting something down that makes some sense. If you make a mistake, I'll still give you partial credit. I mean, when I grade things, I always say, okay, I'm giving you you're starting out with 100, okay? And then what I do is just deduct points. So as long as you put something meaningful down for each problem, even if you mess it up, you know, you'll get something. Don't ever leave anything blank. Because if you leave it blank, I have to take off the full 5 points. Now, as far as when I'll have them graded, that's going to be a little harder because grades are due on the following Monday. And that means I have to post the grades. But the problem is next week, every final that I'm giving my finals don't even start till Thursday. So you're my first final, then I have another final after yours, and then on Friday I have 3 finals. So in 2 days, I'm going to have 5 classes worth of finals to grade, and I have to have it done by Monday. So I will try and get yours done first and get your grades posted. But you know, just understand that I am going to be a little bit overwhelmed at the end of next week with a lot of stuff. So if you do well on the test, it'll be easy for me to grade. They're always easy to grade when everyone does well. That's like encouragement, I guess. Now, what I would say is look at Canvas, look at your grades, and you'll see me update the grades. You'll see the final exam show up, and then you can look at your overall grade. I know that there are some students who took the exam 4 late, and I know I haven't posted those yet. I will post them, don't worry. But let's say Saturday afternoon, you look at your grades and you're concerned about your grades. Email me, all right? Don't text me, all right? Email me what you're concerned about. And the reason I'm saying email me is because I'm going to have a lot of students that are going to wonder about their grades. And so when you text me, I look at it and then, you know, I get 8 other texts that day, and it's hard for me to go back and take care of all that. So if you email it, then it'll be easier for me to go back and check it and figure it out and look at your grades. But don't wait till Monday afternoon. That's what I'm saying. Like if you're really concerned about something, don't wait till Monday afternoon, because once I post the grades, they're posted, and then if anything needs to change, it's got to be paperwork that has to be done, and that means there has to be signatures, including yours and my signature. So this document has to go electronically back and forth through like 3 or 4 different people. It's a real pain in the butt to change a grade after I've posted it. So let's resolve any of that before Monday. What else we got? Do you all want me to do any other problems or anything specifically on the review, the questions, or?
From exam 3, can you do question 1? Like I forgot how to do like the vertex stuff and all that.
Exam 3, question 1. Oh yeah, no. Okay, so I gave you a parabola. Let's look at exam 3 real quick. Well, the instruction, well, maybe I should look at the instructions. Or I should show everyone the instructions. Let's see here. So, oh, wrong exam. It was exam 3. You said that too. Here we go. Here's exam 3. Oh, okay. All I told you was to sketch this. Okay, but I told you before the test, when I say to sketch a parabola, to go through all the different steps. So you'd want to go and, what the heck? There it is. Okay, so you want to make sure you understand the steps to sketch a parabola. And the reason I know it's a parabola is because I have x squared, right? That's what makes it a parabola. If you look at the next problem, I ask you, and I noticed this on the test when people took it. I saw people trying to sketch this using the steps from this, which you can't do because this is not a parabola because it's x to the 4th. I also saw students trying to do this using the steps from this, which is not, again, not what I told you to do in class. This is not where we do leading coefficient test and then, you know, up, down, bounce or touch and cross. That's what we do here, but we don't do that for parabolas. For parabolas, we go through what, 5 steps, 6 steps. First step is to find whether or not it opens up or down. So we just look at the number in front, it's -2. And because it's -2, it opens down. Okay, just stop me, Taylor, or anyone else, if there's something that you don't understand.
Okay.
The next thing was to find the vertex. Okay, so first step was up or down. Then it was vertex. And to do the vertex, we use a formula. So you'd want this on your formula sheet. H is -b over 2a. So you have to identify what B is. B is the number in front of X, so that's B. And then A is that number. And then of course, C is that number. We'll need that later. So I took H is -b over 2A. So I took the opposite of B. So since B was 12, I put -12 over 2 times A, and A was -2. So that's -12. I multiply those, I get -4, and -12 divided by -4 is +3. So that's what H is. And then to get K, the formula for K is just to take the answer we just got, 3, and plug it into the function. I should say the formula is f of h. That's the formula. You plug the answer we just got, h, into f. So that means I had to go in here and I had to replace this x with 3 and that x with 3, and that's what I did here. And when I calculated that, I got 7. Be real careful on that step. A lot of students make mistakes on this calculation, and then this is off and it throws everything else off. Okay, then the next step was a quick sketch. In the quick sketch, what you do is you look at the vertex, which is the 0.37. That means you go to the right 3 and up 7, you just put a dot, and then you use the fact that it opens down to determine that there's 2 x-intercepts. So you can just tell by looking that's going to hit in 2 places. You don't know where, but it's going to hit. So step 4 is to find the x-intercepts. And to find the x-intercepts, you can either factor or you can use a quadratic formula. Now I use the quadratic formula here. -b plus or minus square root b squared minus 4ac all over 2a. You'll want that on your formula sheet for sure. And then you just plug everything in. So I just plugged all those numbers in. And then we're going to have 2 cases, plus or minus. And I get 2 answers, 1.125 and then 4.875. Then we do the y-intercept, and remember to do that. All you do is plug 0 into the function. So if you plug 0 in here, you get -11. And then you plot all your points. You put your vertex here at 3, 7, put your x-intercepts here, you put your y-intercept there, and then you draw a parabola. Is that, am I going too fast there, Taylor, or do you just want like a quick summary like that?
No, just like a quick summary, that's fine.
Okay.
But we can for sure though put like how do you find the H and K on the cheat sheet?
Yes, you can.
Okay.
I mean, if I were you and you wanted to, I would just go back to the notes. Let's see, it'd probably be in October. I would just go back. See, remember this? I mean, this is something we did. This was on the 29th of October. How to sketch a quadratic function. Right. Well, I think we did it before this actually. All right. See this steps to sketch rational function. I would write all that down on my formula sheet if I were you. That's what I would do. I mean, I'm telling you, you can do this. You can write down all the steps.
Mm-hmm.
Okay, so put those on there. Let me see. That formula right there, an object, you know, falling object, I would put that there.
Could you go over the falling objects?
Do what?
The falling objects, can you go over that?
Let me see. Depends on whether or not I asked you. Let's see, is it on the review? Let me see, did I ask you to do that? That would have been on exam 3. Number 4, let's see. Yeah, so it's like this one right here. So it'd be a problem like that. So you want me to go through that? Something like that? Yeah.
Yes, please.
Okay. So a rock is thrown upward. Do you want me to do that one, or you just want a different one? What do you want me to do?
No, you can do that one.
Okay, so a rock is thrown upward. Let me just bring up the solutions because I think that'll work a little, be a little faster if we do it that way. So this is exam 3. And it was the last one here. All right, so the big thing here, they said a rock is thrown upward, right? Just grab this. Okay, I'm just going to put it right here. So when this problem says that a rock is thrown upward and starts, you know, falling back to the earth from a bridge, right? This is where you have to know to bring in a formula. So this is where you'd have to go back to your notes, and this is why you'd want this on your formula sheet. You would want this right here, because this is the formula we use when an object is falling on Earth. All right. So I'll just grab it. I feel like crap. All right, so here's our formula. So it says a rock is thrown upward from a 20-foot bridge. So what I did in this formula is this number out here is the height of the object when you start. So this, I put 20 here, and that's from the 20-foot bridge. It was given an initial speed of 30 feet per second, okay? That 30 feet per second is the number in front here, okay? So I put a 30 there. And then everything else stays the same. And that's why for part A, it says, find the quadratic function which gives the rock's height as a function of time. So this is the answer. But do you see it's just this formula with this right here replaced with 30 and that replaced with 20, right? So that's the first part. You're just setting up the equation, but you have to have this. in order to do it. So you make sure you write that down. And then it says, when, at what time does the rock reach its maximum height? And then what is the maximum height of the rock? So the idea here is that if we were to graph this, which you're not required to do this, but if you graphed it, this would be a parabola that opens down. And so when it says, when does it reach its maximum height and what is the maximum height? That's when you have to realize we're talking about the vertex. And this is H and this is K. So remember, it's a point HK. The H is always going to represent the time that it takes, and then the K is always going to be the height. So basically part B, saying when, at what time does the rock reach its maximum height, is asking us to figure out what H is. And when I ask what the maximum height is once K. So that's what I did here for part B. I found H, and H is the vertex formula that we just used. It was, I'll just slap it here, negative B over 2A. So I went in here, A was negative 16, B was 30, C is 20. So I put negative B, so I put negative 30 right here, over 2 times A, so 2 times negative 16. I multiply that together, I got my calculator out, and I got about 0.9375 seconds. That makes sense? Okay, and then the next thing is I found K, and to find K, I took that answer and plugged it into this thing, and I had to get on my calculator and do that. So here's me plugging it all in. And then I got about 34.1, and that's how many feet. And then the last question says, how long does it take the rock to hit the ground? Well, that has to do with the x-intercept. That's us trying to find that x-intercept right there. Now, there is another x-intercept back here, but we don't look at it because that's a negative value. So to find the x-intercepts, I take this quadratic and I use a quadratic formula on it, which is here. And then I do all my work. And because this was the solutions, I just put the positive answer. I didn't even put what the negative answer was here. So that's 2.39 seconds. Does that help?
Thank you.
Yeah?
Yeah.
Okay. Oh my goodness. Okay, what else? No? Okay, so I have 2 graphs here. All right, I'm giving you this because this is one of those problems that I'm supposed to give you that I don't feel is really fair. So I'm going to give you a little kind of hint about the problem. So look at this graph, okay? And then look at this one. And I'm going to give you a hint here. One of these is linear growth and the other one is exponential growth. Can somebody tell me, because these two graphs are different. Let's see, here's graph A and graph B. Which one of these is linear and which one is exponential? So what do you think? Does anyone have a guess? I'm giving this to you so we can talk through it, okay? I don't expect you to necessarily know exactly how this is being done, but I want you to just contemplate this. Which one of these does it look like is growing linearly, and which one of these do you think is growing exponentially? Any sort of guesses?
A is probably linear.
Okay, what would make you say that?
Well, B looks like it's like, oh gosh, I can't even explain it, but
It's kind of like growing faster.
yes.
Okay, so look at the differences. This one's 20 and then it goes to 42. That's a jump, right? That's a jump by about how much? About 20? That jumped up by about 20, didn't it? And then from here to here, it jumped about 20. Okay, it's not exactly 20, but it jumped about 20, right? And then from here to here, it jumped about 20. Then from here to here, it jumped about 20. I know it's not exact, but it's approximately. It's just going up by the same amount each time, isn't it? Same amount each time. That's linear. That's like if you're making, let's say you make $12 an hour. Then every hour you work more, you make 12 more each time. This is what's happening here. As we move to the right, it just keeps getting bigger by about 20 each time. Look at this one. It jumps by how much? About what? What do you think? I don't know. It jumps by 3, doesn't it? Okay. What does it jump here? Jumps by what? 6, right? And then from here to here, it jumps by what? So like 13. Is it growing by the same amount each time? Is it jumping by the same amount each time? Not even close, right? You could almost argue that it's almost like you're doubling it each time. Like 2 times 2 would be 4. That's close to 4. And 5 times 2 would be 10, but that's close to 10. And 11 times 2 would be 22. It's close. So here it's like doubling each time, right? Doubling. As opposed to here, it's not doubling each time. It just keeps going up by 20. So if you look at a graph and you go from one value to the next and it grows by the same amount each time, that's linear. But if you're growing and it's not the same each time, it's not the same jump. Like here, it looks like it doubles, like 3, and then that doubles to 6, and that doubles to about 12, 13. See how it's doubling? Anything that does that is exponential. That's all I can give you. I can't give you any more. Do you have a question on that though? I don't know who answered originally when I asked the question and they said that this just looks linear. I mean, go with your instinct, okay? Go with your gut. If you're taking the test, just go with your gut. You're either gonna be right or wrong, but the technical way to do it is just to look at what's happening as you go from one to the next. And if those numbers are the same or close to the same, then it's linear. If these numbers change, if they're different, significantly different, then it's exponential.
Can you also go over on the review exam 1 question 4?
Exam 1 question 4. Yeah, I can do that. So this was order of operations, right? Pemdas. Right, our good old Pemdas. What the heck is that? That's really weird. Okay. So PEMDAS. And remember, multiplication, division goes together left to right, and addition, subtraction is together left to right. So you're going to do everything in parentheses first. And I see two sets of parentheses. I see one here, and I see one here. So it doesn't matter which order we do these. I'll start with the one on the left. I need to do everything in here first. So I'm taking 4. I'm subtracting a -1. Anytime you subtract a negative, it becomes a plus. So I'm just going to rewrite this 4 + 1. And then plus, now in this parenthesis, I'm going to go ahead and start looking at what this is. These bars around the -3 means absolute value. And the absolute value of -3 is just that number positive. So the absolute value always spits out the number positive, no matter what. If it's negative, it spits out positive. If it's positive, it spits out positive. So that is just 3, and then take away 5, and then I still have to square it. Okay, that's my first line. Let me keep working. -2, now I'm gonna go ahead and do 4 + 1, that's 5. So I'm gonna have 5 there. And then plus 3 take away 5 is gonna be -2, so I still need that in parentheses, squared. Now I'm going to square -2 because exponents comes next. Exponents, so -2 squared means -2 times -2, and that means +4. Negative times negative is positive, right? So this gives me -2. This is multiplication, that's a times, but I'll get back to it in a second. +4. And now I've got to do this multiplication. That's a dot between those. So -2 times 5, that gives me -10. And then +4. And if I add those together, I get -6.
The absolute value is always going to be positive.
Always.
Like they're in the bars.
Yep. So if you have absolute value of 4, your answer is 4. But if you have absolute value of -4, your answer is also 4.
Okay.
Okay. Yeah, all the absolute value is doing is this. If you take the number 4 or the number -4, it doesn't matter which one you do. If I were to ask you, what's the distance from here to here? Like if you were to get a measuring tape out and measure the distance from 0 to those two numbers, they would both be a distance of 4. And so that's what the absolute value is doing. It's asking you, what is the distance from this number to 0? And so your answer will always be positive. All right.
Can you also go over number 6?
Sure. Can I get rid of what's up here? Clear that out.
Yes, you're good. Thank you.
So this one, solve for x. All right, so to solve for x here, my recommendation would be, and what I showed you all in class, is to get rid of the fractions. To clear the fractions, that would be the first step. And you know what? Going back to, this again is, how do you review for a test like this? Go back to, geez, I would say this probably be in September. Here, oh, look at that, I found that pretty quick. September 3rd. Solving linear equations in one variable. Here are the steps. Clear the fractions. Remove parentheses on both sides. Collect like terms. Isolate the variable on one side of the equation. Make the coefficient of the variable 1. Okay, so these are steps. If you want to write those down, you can. Shoot, I forgot what I was doing. Where are you? That one? Okay, so this is a linear equation. So what I'm going to do is clear the fractions. So I look at the denominators. I have a 5 and a 3. So what I need to do is find the least common denominator, which would be a number that is a multiple of both of these. So the smallest number that you can think of that is a multiple of both of these, that would be 15. Right, 15 is a multiple of 5 and a multiple of 3. Does anyone remember what I do with that 15?
Don't you change the denominator to 15? Sir?
You can, but because we have an equation, there's a faster way of doing it. You just multiply the whole left side by 15, and you multiply the whole right side by 15. Okay, so I took the left side of the equation, I multiply it times 15. I take the right side of the equation, I multiply it times 15. Now, when I do that, I have to distribute the 15 through the parentheses. That's because I had 2 terms on the left side, so I have to distribute that through. And let's see, I'm going to go real slow here. This is the same as 15 over 1 times x over 5 minus 15 over 1 times 5 over 1. Well, you don't really need that. I guess we don't need that. We could just say 15 times 5. And then equals on the other side, that's going to be 15 over 1 times 5x over 3. Okay, so from here to here, I rewrote 15 as a fraction so I could multiply these. And remember how we multiply, we go straight across. 15x over 5 minus, and then here, 15 times 5, 75 equals, let's see, 15 times 5, that's 75x over 3. Do y'all understand what I'm doing there? Is multiplying straight across, multiplying straight across, just multiplying those together. Now, we do get fractions to reduce here. Okay, so like this reduces and this reduces. And that's the whole point of this whole thing, is that 15 divided by 5, that's 3x minus 75 equals 75 divided by 3 is 25x. And now at this point, we have a nice linear equation with no fractions. So we will get all the x's on one side. So I'll subtract 3x here, subtract 3x here. They go away. Over here, we get 22x equals negative 75. And then the last step would be to divide both sides by 22. 22 is canceled. We get x equals negative 75 over 22. Did that help? Is that clear? Yeah.
Yes. Thank you.
Usually when I do math, I start feeling better, but it's not working today for some reason. Let's see, I had sent you all the solutions. Let's see, for exam 1, I didn't even ask the student. I'm using a student in the class. I don't see the student here right now, but I use their work. Let me see. Did I not include that one? Okay, either way. Well, it's 10:30. Got any other questions? right, well, I guess in that case, we'll call it a day. And we'll call it a semester, almost. We'll have to wait till next week to call it a semester, but I appreciate everyone's attendance this semester, and especially those of you who've kept your cameras on. I really do appreciate that. I'm gonna keep that in mind when I consider your grades and bonus and all that. And I know this has been difficult for all of us to adjust to, but I commend you for hanging in. And I wish you all, because I probably won't talk to a lot of you after this, so I wish you all luck moving ahead in whatever it is that you're going to be pursuing academically. And I'm always available to you down the road if you have any questions, need any help with anything, letters of recommendation, things like that. Just let me know. And good luck with all your other finals. I think by the time you take the one here, you'll probably be done with most of your other finals. So good luck with all that. I think part of being a good college student is trying to figure out how to manage a bunch of exams in 1 week. That's kind of what it's all about. Is can you get your brain to have all this information in it, and take these tests back to back. And it's a lot of pressure, but anyway, good luck with those. Thank you. And if you need me, you know how to reach me.
Thank you, sir.
Alrighty,
Have a
thank
good
you,
day.
sir.
So.
Good one.
Thank you.
Take care.